Very good morning to everyone. In this lecture, EC 8351 Electronic Circuits 1 Department of Electronics and Communication Engineering, third semester, Unit 1. In previous session, we are going to discuss the biasing method of BJT configurations. What is the stability factor of the BJT configurations and what are the compensation technique we are following the BJT configurations. Now today we are going to discuss the various biasing method of UJT, that is a Jfet, junction field effect transistor. Here the parameters of FET is temperature dependent. When temperature increases, the drain resistance also increases, thus reducing the drain current. Like a BJT, the thermal runaway does not occur in the FET. However, the wide difference in maximum and minimum transfer characteristics make the drain current levels unpredictable with a simple fixed gate biasing voltage. So we have to differentiate biasing circuit of FET is also the three category. Number one, fixed bias circuits, cell bias circuits, voltage divider bias circuits. Let us move to the fixed bias circuits of Jfet. The fixed bias of Jfet, the DC bias of FET device need setting of gate source voltage to give desired drain current ID. For a Jfet, the drain current is limited by the saturation current IDS. Since the FET has such a high input impedance that no gate current flow and the DC voltage of the gate set by the voltage divider or fixed battery voltage is not affected or loaded by the FET. So here the circuit diagram for a fixed biasing circuit of Jfet configurations. So the Jfet is a 3-terminal, that is a gate and a source and a drain. So the input signal, we are applying the gate to source voltage and the output voltage is applying the drain to source voltage, that is a VDS. We have to get the output of the drain side. So here the fixed bias DC is obtained using a battery of VG. This battery ensures that the gate is always negative with respect to source and no current flow through the resistance of RG. And the gate terminal, that is gate current is equal to 0, the battery provide a voltage, that is a gate source voltage, to bias the N channel Jfet, but no resisting, that is a resulting current is drawn from the battery VGG. The resistance of RG is included to allow any AC signal applied through the capacitor C to develop across the gate's resistance. While any AC signal will develop across the gate resistance, the DC voltage drop across the gate resistance is equal to the gate current, that is unto the gate resistance, therefore the 0 volt. Now we can calculate the gate source voltage, that is the input side voltage for DC analysis of the gate current is equal to 0. It is the initial condition for applying the Kirchhoff's voltage law to the input side of the circuit. So now we get the equation of the gate source voltage plus the threshold voltage is equal to 0. So the gate source voltage is equal to the negative of the threshold voltage, that is a minus VGG. As the gate source voltage is a fixed DC supply, hence the name as a fixed bias circuits. Now we can calculate the output side of the charge, that is a drain current. So the drain current IDQ is equal to the ID into IDSS, that is a saturated drain current, into the 1 minus the input voltage into the VGB whole square. Now we can calculate the output voltage drain to source voltage. This current IDQ then causes a voltage drop across the drain resistance RD and is given by VDSQ is equal to the threshold voltage minus of drain current into the drain resistance. Now we can move the self bias circuit of the Jfet configurations. Here the self-biased circuits, the self-biased circuit is almost constant. That is a common method for biasing a JFET. The self-biased circuit for N-channel JFET, the gate source junction of JFET must be always in reverse bias condition. So no gate current flow through the reverse biased gate source. The gate current Ig is equal to 0 and therefore the gate voltage is equal to the gate current into the gate resistance is equal to 0. When a drain current ID, the voltage at the stability is source resistance is equal to the drain current into the source resistance. So now the gate to source voltage is then the gate source voltage is equal to gate voltage minus gate source voltage is equal to the gate voltage is initially 0. So what are the output voltage? That is a drain current and the source resistance is nothing but the negative of drain current into source resistance. We have to see the cell bias circuit of N-channel JFET. So the voltage across the resistance of RS, it provide the biasing voltage VGS and no external source is required for biasing, and this is the reason that is called the cell biasing. The second condition, it calculate the drain current in the cell biased circuit of the JFET configurations. The drain current is equivalent to the drain source saturation current into the 1 minus of gate source voltage into the pinch off voltage into whole square. So these are the analysis of the cell bias circuits and also the fixed bias circuit of the JFET configurations. Now, in this configuration, these two configurations, we have to improve the stability factor of the JFET configuration, that is a unijunction transistor model, to improve the output voltage. So here it is a voltage control device, that is a UJT is a voltage control device to improve the stability factor of the voltage level. So we have to consolidated, we have to analysis the input of gate source voltage and also the output voltage. We get the collector output current, that is a drain current of the output. We can stabilize the output voltage. In upcoming session we are going to discuss the voltage divider bias configuration of JFET configurations of transistor biasing. Thank you for watching this video.